Günaydın. Günaydın? Oh, okay, thank you. It's very hard for a Texas boy to say Turkish. Okay, so I was worried maybe I'd said the fish is ready. Okay. I am very, very excited to be here today. What a great opening, energetic introduction we had. I want to welcome you all to Autodesk University Extension, Istanbul. Today, we have a program that's going to give you great opportunities for learning, for networking, and hopefully for inspiration as well. Because we are here to talk about our future of making things. And that is a very, very interesting future indeed. Now, one of the great things about my job, and I run the global enterprise sales organization for Autodesk, is I get to travel all over the world. And every year I meet hundreds of Autodesk customers like you. And they're all very diverse, and they're very diverse in their jobs and their industries, but there are some things we all have in common. One of those things is whether we're digital artists, engineers, designers, we're looking for tools and technology that will help us unleash our creativity, help us solve tough technical problems, meet our business challenges. But there's another thing we all have in common, and that is we are on a shared journey, an ever-accelerating ride into the future, that future that we call the future of making things. That future, I believe, is very bright, but it's also a future filled with disruption. The way we do our jobs today may look very, very different in just a few years. And the thing about disruption is disruption brings tremendous opportunity if we take advantage of it. But it also brings tremendous risk if we ignore it because somebody else may take advantage of it at our expense. So what is this thing that we call the future of making things? It's really a collection of ideas, of major trends that we believe are driving and impacting almost every industry out there today. And we classify these trends into four main categories. And I'm going to give examples today of each of these, but let me just start with this overview. First of all, there are significant trends that are going to change the way we design, whether it's a building, an automobile, or a movie or a game experience. There are significant changes in the way we will collaborate with our partners and our customers, and the way we will leverage technology and it will collaborate with us. Not only are we changing the way we design, but we're going to change the way we make things as well. The means of production are moving at a very rapid rate. And we could talk about a lot of technologies here. We could talk about advanced materials like composites. We could talk about microfactories. We can talk about additive and subtractive manufacturing processes. And we're going to address many of these things today in the conversation. But we also need to recognize the connection between design and production are becoming tighter because they have to be. We have to understand how things will be made in order to design them correctly. Even our expectations about the products themselves is changing. We have an expectation that products will be smarter, that they'll be connected, that they will get better over time. Traditionally, an item that is manufactured becomes obsolete the day it's sold. It begins to depreciate. It's a dead artifact. But increasingly, we're building products that are sensored. They're wired and connected to their environment. They're connected to us. They get smarter. They learn us. A great example would be the Tesla vehicle, very famous electric car made in California. A couple of years ago, the Tesla was suffering in their automatic suspension from certain driving conditions would cause the bottom of the car to hit the ground under certain kinds of turning conditions. In the normal world, this would require a redesign and a recall of that product, but not for Tesla. They rewrote the software, and because all their cars are connected, they were able to upload the fix, and the next day all the cars were a centimeter higher. They didn't hit the ground anymore. And finally, we believe that there are changes in the demand that people are putting on products. And these come in a number of categories. First of all, we're all becoming more conscious of the social and environmental impact of the things that we buy and the buildings that we work and live in. Were there workers abused in some country in order to make this thing we have? Did we increase our carbon footprint by buying this automobile? What happens when the product is done? Does it go into a landfill? Does it pollute the water? These are questions that consumers are asking more and more. But there's another trend in the nature of demand as well, and that is consumers today expect products to be tailored to them. They want products, whether they're automobiles, clothing, almost anything, to reflect their personality, their body type, their expectations in life. They want things that are built for them. They're not necessarily ready to pay a lot of money for these bespoke capabilities. But here's a great example. You know what we're looking at here? These are earbuds, like on an iPod or an iPad, iPhone, earbuds. There's a company in New York called Normal, and Normal has an app that you download on your phone, and you take a picture of your ear, and that picture gets sent to the company, and with that data, they create a 3D model of the shape of your ear. And in 48 hours, they custom 3D print an earbud that fits your specific ear and mail it to you. These are the kinds of things, and this is a simple example, but these are the kinds of things that will feed this demand for products that are tuned and suited to me. All right. So we have these 4 big areas of disruptive trends. The way we're going to design things, the way we're going to make things, our expectations of the products themselves and their intelligence and their connectedness, and the changes in the very demand from our customers and our consumers and from ourselves. And for the rest of my talk today, I want to give you some examples because I love that quote from William Gibson, the quote that says, "The future is already here today, it's just not very evenly distributed." Well, I'm going to give you some examples of where it is distributed and where companies are already starting to do some really amazing things. But to make it manageable, I'm going to break the conversation down into 3 main phases of the life cycle of any product, any building, anything we make. There's a design phase, there's a make phase, and there's a use phase. And these phases traditionally have been very separated in the way we approach them. The design team, the industrial design team, may be very separate from the manufacturing or the engineering teams, and neither of them may communicate much with the sales team or the product support team who actually have to deliver this to their customers. But these things are becoming very tied together, and I'm going to talk about how these disruptive trends are impacting these 3 phases. Now, before I get into it, I want to say one more thing about an underlying technology that I believe is so compelling, we have to understand how it's enabling much of this disruption. And Autodesk has taken this technology very deeply into our strategies and the way we design and build our future products. And that technology is the cloud. And let me tell you why I think it is so compelling for us to understand this fundamental enabling technology. Autodesk is 34 years old as a company, okay? And there's a reason why we are 34 years old, because in 1982, when the company was founded, this was the beginning of the personal computer era. Our founders recognized that the PC represented a fundamental step change in the cost and availability of computing as a resource. Prior to this, computing was a scarce resource. It was something on a mainframe or a mini computer. Large companies could afford them, people could not. But what the founders realized is that with the PC, computing could go broadly. It could go everywhere. Anyone could afford a computer. What might we do with that? And that is how Autodesk was born. Well, today, 34 years later, we have our next big step function, excuse me, in the cost and availability of computing, and it's called the cloud. Many of the ideas we're going to talk about today, virtual reality, generative design, collaboration, mobile technologies, and so forth, these ideas aren't new. But with the cloud, we now have an economically viable, cost-effective, technologically viable way to implement those ideas, and that is what's going to enable this future of making things. All right, so let's look at an example. And we're going to start with the design category. You know, one of the big things we see in the future of design is it becomes increasingly collaborative. Increasingly collaborative. Design teams, engineering teams in very different geographic locations able to work together seamlessly as though they were in the same office. But it's not just collaboration across time and space, it's also collaboration across different disciplines, helping these disciplines work together to produce new kinds of artifacts. And here's a great example. This example comes from Russia. There's a company there called Callan, and they were very good at 3D printing. They understood 3D printing very well. And they recognized there was a need in Russia for prosthetics for children. Now the problem was prosthetics were available, but the prosthetic limbs were simply cosmetic. They didn't work. They didn't hold anything. They couldn't actually throw a ball. If you wanted to have a hand that worked, it would be very, very expensive. So Callan reached out to another company, EAWS, a Russian robotics firm, and together, even though they were in different cities and had very different expertise, they were able to collaborate and build a solution that was 85% cheaper and could be custom fitted to a child in a week. All right? What a great example of collaboration. Now here's another example of collaboration and the way we're changing design. Ford Motor Company, one of the largest automobile companies in the world, they invented the automobile assembly line. Been around a long time. But like all automotive companies, they're under pressure. They're under pressure to evolve their products to meet these changes in demand I talked about earlier. Cars are no longer just mechanical things. They're thought of as an experience. An experience. How do I feel when I'm in that car? What do I think about myself and my life because I own it? So in order to design an experience, you have to bring together a lot of different teams. Industrial design, engineering, manufacturing, and many others. And Ford was struggling with doing this effectively. So meet Elizabeth Barron. Elizabeth Barron created the first virtual reality lab at Ford, and she now runs it today. And I'm going to let them tell you how they're using this to change the way they design.
We're here in the virtual space of the Product Development Center in Dearborn, Michigan. Here in the virtual lab, we assess high-definition renderings of the vehicle to overall improve quality and appeal of the vehicle.
In this space is a full-size virtual vehicle that we can evaluate for many different aspects of engineering and design and look at it from the customer's perspective.
We put the head-mounted display over your eyes so that you have computer screens in front of your eyes effectively, and then we track where those are relative to this space, and then we put the CAD information over your eyes, and then we're tracking where you are relative to that CAD information. So you can walk around and interact with the entire vehicle.
And then we give you tools which are very similar to what you have in the physical world to look at the car and evaluate it for quality.
So the biggest benefit is the ability to have a realistic vehicle much, much sooner in the product development phase.
We can represent them in our software instantly to show many of the different possible combinations of builds that could come off the line, and then we can make educated decisions on whether or not this is going to be acceptable or require an engineering change.
The way we have set this up is we're able to collaborate globally. So we can have representatives who are immersed in their virtual space, and we're immersed in our virtual space, and we can look at each other and talk to each other in real time on different continents inside the same model. So we have upgraded the software capability as well as the hardware capability, and so the vehicles that we see now are incredibly lifelike. We're showing that stereoscopic view in real time to a person or multiple people around the world, and then also in 4K. The level of detail that we can focus on now is amazing, and the customers see that in the end.
I've been in this lab, and it's pretty funny to watch people crawling around on their hands and knees in an empty room looking at something you can't see. So they're looking underneath the car, they're looking inside the car. It's really an amazing experience, and if you ever get a chance to try it, you absolutely should. So we've talked about design changing because of collaboration over time, over space, and between disciplines. I'm going to talk about a different kind of collaboration that we believe is going to be really important for the future of design, and that is collaboration between human beings and the computer. Now, up until recent times, computer-aided design really should have been called computer-aided documentation, meaning the design was in the head of the engineer, the artist, the designer, and they captured it in the computer. But what if we could turn the computer into a co-designer with us? And that's the idea behind generative design. Generative design is the idea that we can give a computer a well-defined description of a problem and take advantage of the almost infinite, almost free compute resources that we have from the cloud to generate tens of thousands of alternative solutions optimized against constraints and goals that we give the computer. Here's a great example of that. Airbus, one of the world's largest aircraft manufacturers, a couple of years ago began working on a concept plane called Airbus 2050. They're rethinking everything about their aircraft, the materials they're made from, the way the seating is laid out, the experience that we would all have as travelers. Now, this looks pretty futuristic, and it may be some years before we have an airplane that looks like that. But there are pieces of it that are being built today, step by step, to take us to that future. And here's a great example. You see this red thing here. This is this bulkhead, this partition in the aircraft where the flight attendant's seat is attached so they sit down during takeoff and landing. These things are important. They have to be strong, but they also need to be lightweight. Now this design, it's got a honeycomb center. It's been around for decades. There's nothing wrong with it. But the people at Airbus came to Autodesk and said, is there a way we could make this lighter, more functional, and yet not lose any strength, because strength is really important in an airplane? And the answer is yes. So we took the constraints, we took the forces and the loads required, and we fed it into an algorithm. And this algorithm was able to look at different manufacturing options, look at different techniques for achieving a lighter weight while still maintaining the strength and flexibility requirements. And in fact, we were all a little bit surprised because not only did they get something that was half the weight, it was twice the strength. And the design was something very non-intuitive. No engineer would have sat down and designed a lattice that looks like this. Well, this isn't just something in a computer model. This bulkhead has been manufactured. It's currently in flight testing at Airbus, and who knows, maybe by this time next year, if I come back to Turkey, I could be riding in an airplane that has one of these bulkheads. By the way, what's the big deal about this bulkhead? Well, it saves 25 kilograms of weight without sacrificing strength. And for an airplane company, weight equals fuel equals cost. By just replacing that one bulkhead in their fleet of aircraft, they will reduce carbon emissions by the equivalent of 96,000 automobiles a year. Think about that. That's replacing one part. Imagine if we start to replace the rest of the airplane with these kind of technologies. All right, so we've talked about the future of design. Let's shift over and talk about the future of making things, the production piece of this. How do we construct things? How do we manufacture them? I'm going to start with an example from a company called Connextech. Connextech is a startup company not too far from Autodesk headquarters, and the founders there had a vision. They had a vision to make steel frame buildings simpler, cheaper, and more precise in their construction. And what they did is they came up with a special dovetail that allows you to take a prefabricated beam and attach it to an engineered column simply with bolts. No welding, no riveting on site. And in fact, they even improved the manufacturing process of the beams themselves by coming up with a really unique horizontal welding process for welding the brackets onto the beams that runs 30% faster than vertical welding at the construction site. But here's the result. They can now build a 1,000 square meter building in a day by assembling these beams and bolting them together. The one you see here went together 8 men, 7 hours to put this together. And it's not just about speed, it's also about the beauty of the result. And here's a great example. This is the neuroscience lab at Stanford University built using this technique. It was fast, it was cheap, and it had a beautiful result. And what this really highlights is that one of the major trends in construction, of course, is that construction is looking more and more like manufacturing. Construction sites are becoming open-air factories, and that changes the way we think about buildings at a very deep level. Let me give you another example from the world of AEC. A company called McCarthy Construction. Now, McCarthy have a very simple vision. They simply want to be the best construction company in the world. And they recognize if they're going to be the best construction company in the world, they have to address the key limitations that all construction companies face, and that really is in the ability for their employees and their partners to effectively collaborate to build these complex structures we call buildings. And they build some pretty complex things at McCarthy. Here's an example of a state-of-the-art aquarium being built in Arizona. Now, this aquarium is huge. It's 18,600 square meters on 3 levels. It has 1,000 kilograms of structural steel. It has 1,900 cubic meters of concrete. And McCarthy realized that they've got to find a way to reduce errors, reduce clashes at the site, realizing they're building something that was very technically advanced. So they started using cloud technologies. They started leveraging cloud technologies to collaborate, BIM models, of course, to provide the basis for a common data view. And they were able to build this aquarium in 35% less time than they ever had before. And not only that, by bringing the BIM models to the construction site via mobile technologies like BIM 360, they saved 17,000 man-hours. A real success story. And they're well on their way to their goal to be the best construction company in the world. All right. You can't talk about the future of making things and how we produce them without talking about additive. Additive technologies, we think, are going to be a game changer in many industries. Now, when many people think of 3D printing, they think of the sort of hobbyist 3D printer, the toys. But that's not what we mean at Autodesk. At Autodesk, when we talk about additive manufacturing, we're talking about industrial 3D printing. And here's a great example. This object here in front of you, anyone have an idea what that is? It's a heat exchanger. This is an incredibly efficient heat exchanger. By the way, it was designed using generative design. The algorithm was given size constraints, the thermal properties that were required, and it was generatively designed by the computer. If you look inside of it, it has randomized flow tubes for the fluid in order to maintain turbulent flow throughout, maximizing heat transfer. This is not something a normal rational engineer would have come up with. Even worse, you can't mill this, you can't cast it. It was 3D printed in aluminum. Generatively designed, 3D printed in aluminum, a fraction of the weight and much more efficient than the traditional heat exchangers it's replacing. And I'm not just talking about things the size of a heat exchanger. This building is 3D printed. In China, they are now making very low cost, very rapid housing for people using 3D printers at a structural scale. In fact, at Autodesk Research Labs back in San Francisco, we have a project called Project Escher, where we're printing 5-meter-long objects, okay? So 3D printing is no longer for toys. It is an industrial methodology that is here to stay. Here's a last example, and this is an example that's actually up in the gallery here upstairs. Under Armour, very famous athletic clothing maker. They came to the market in 1996. So this year is their 20th anniversary. And to honor their 20th anniversary, they wanted to build a unique athletic training shoe, one that had unique properties, cushioning the athlete during the most strenuous training, reducing stress, reducing injuries. So what did they do? Once again, they turned to generative design, and they created a heel that is unlike any heel that you've ever seen before, using generative design methodologies. Once again, they didn't have an easy way to make it. In the end, they 3D printed it. So now what we have, and as I said, you can see this live upstairs, is the world's first 3D printed sole for a training shoe. All right, is the future of making things just for airplanes and shoes? No. We can also talk about how the future of making things is changing the way we do movies, games, and other forms of entertainment. So I want to introduce you to a little company called Atomic Fiction. Now, Atomic Fiction is a visual effects studio. They do visual effects for movies and television shows and commercials, and they have to compete with the biggest visual effects companies in the world. But they're small. How were they going to compete with the big guys? Well, they recognized, going back to this idea that the cloud changes the way we think about how we use compute technology. They leveraged the cloud to create competitive advantage. They can build a virtual pipeline instantly, on demand, for applications, storage, rendering, the overall asset management of the process. They're able to get scenes rendered and back to them in an hour that used to take 10 hours. This keeps the ideas flowing in their creative department, and it's the creativity that distinguishes a company like this from their competitors. And is it successful? Yes. This small company is winning major motion pictures, major television shows. For example, The Walk, a very famous story about a Frenchman who walked across a cable between the Twin Towers in New York City. It's not just The Walk. Star Trek, Game of Thrones, The Empire, all major entertainment shows won by this small company because they leverage the power of the cloud. The message here is that the traditional barrier to entry that comes from having a big capital investment in a factory, in a rendering farm, in whatever, that may no longer be a barrier to competition because much smaller competitors can come and do clever things with technology that level the playing field. All right, the last category, use. We've talked about design, collaboration, virtual reality. We've talked about make. Now we're going to talk about use. What happens when that product goes out into the world? Well, of course, what I'm talking about is the Internet of Things. And this idea is really powerful, that we have low-cost sensors, we've got wireless networks, we have the ability to stay connected to our customers after they've bought the thing that we built for them. This opens up new opportunities for relationships with those customers. It opens up new revenue streams. I don't just build the building now, I'll help you manage it because I've censored everything about the performance of that building, and I have the big data to help you run it efficiently. Here's a great example, something we've probably all experienced, flying in the wintertime. One of the most miserable things about flying in the wintertime is waiting for the de-icing truck to come and de-ice your airplane. And I fly about 300,000 miles a year, so I've experienced this more than once. Back in 2008, there was a terrible blizzard in Seattle, and that blizzard essentially ended up shutting down the airport. 450 flights were canceled. 4,000 people were stranded in the terminal that day. Why? Well, for a very simple reason. They ran out of de-icing fluid. They ran out of de-icing fluid because planes were de-iced, and then they had to wait, and then they had to be de-iced again. Nobody was managing the flow of the fluid. The companies didn't know whether they had supplies available for backup or not. This was a disaster. And the company who builds that equipment, Premier De-icers, it really caused them to step back and look at their whole value chain, the whole process of how de-icing runs. And what they did is they went out and they censored everything. They censored the trucks, they censored the de-icing stations, they censored the delivery vehicles, and now they can tell you within 7 seconds how long it's been since every plane in North America has been de-iced, how much fluid's been used, when will they need to be de-iced again if they don't take off on time, how much de-icing fluid do they have in reserve, and how much is on the delivery truck on its way to replenish them. And they've built themselves a dashboard that allows them to manage their business in a way that they will never get caught without any de-icing fluid again. Here's another example of how we can think about using the Internet of Things and using big data to change the way we design. What you're looking at here are some crazy guys called the Bandito brothers. They are Hollywood stuntmen, they're movie makers, and they hold a number of records for doing really crazy things. They have the longest car jump in the world. They have the first twisting car jump in the world. They were the first to do the double vertical loop in a car. Well, their current project is something called HackRod. What is HackRod? They are taking, or have taken, a race car chassis, and they are censoring every aspect of that vehicle. They wanted to understand every force, torque, strain, stress that occurs in the chassis of that vehicle as it's being driven around a high-performance test track. They even censored up the driver, measuring pupil dilation and heart rate and things like this to try and get a sense of what is his experience in different phases of the driving. Now, what are they going to do with all this data? At the end of the day, they now know everything about the forces that act on that chassis in every phase of driving. So what do they do with it? Well, you can imagine they went to generative design. They took all that data and turned it into constraints for one of our generative design algorithms, and they said, now that we know the forces that chassis is going to experience, design me the most effective chassis you can. And by the way, do it multiple times. I want to see it in titanium. I want to see it in carbon fiber. I want to see it in steel. Amazing use of sensors and the Internet of Things feeding directly back into the design process. All right. Design, make, use. The future of making things is going to impact all of these phases, and I only have one last example to share with you, and in many ways it ties together all these concepts in a really cool application. I want to introduce a company called MX3D. MX3D is based in Amsterdam, the Netherlands, and these guys view their mission is to analyze, predict, and make the future happen. So they get involved in all kinds of projects. And their latest project is to build the world's first completely autonomously designed and constructed bridge. Okay? So they've taken a canal in Amsterdam. They know the distance across the canal. They know how wide they want the bridge to be. They know the force vectors that the loads the bridge has to support. And they fed that into an algorithm, and the computer has generated a design for that bridge. But what's more is they've taken 4 robots that have the ability to 3D print steel in the thin air. Okay? Starting this month in Amsterdam, they're placing these robots, 2 on each side of the canal, and they're going to start printing their way to the middle until they meet. And this is the location where it's going. The world's first completely autonomously designed and constructed bridge. That's pretty cool. And who knows what they're going to learn from this experiment that will change the way we design things going in the future. So at the end of the day, as I said at the beginning, I think the future of making things is really bright. Full of disruption, yes, but full of opportunity for all of us. And I think our job and your job is to make sure that that William Gibson quote, that the future is already here, it's just not evenly distributed. Your job is to make sure it is evenly distributed in Turkey. Thank you very much, and enjoy the rest of AUX.